Good morning, ladies and gentlemen of Algebra 2. Yesterday we started looking at factoring trinomials of where a is greater than 1. And so that brings some complications. So this first one is going to be number 1 on your sheet that you have here. We looked at taking out a common factor first. And if you remember that 5 is a common factor to these 3 terms. So 5, you have 5 times x squared minus 2x minus 3. Is that right? And then if you could further factor this trinomial here, we looked at if you set it up as a box like we've done in earlier episodes, you come like this, and then you know that x squared is going to go here, and negative 3 is here, and you have x and x. And then you ask yourself, what 2 numbers, when multiplied together, equal negative 3, but added together equal negative 2? Well, if you recall, we had, if you take negative 3 and 1, and then you have negative 3x here, and you have positive x here, then you add these together, you get negative 2x. So the factored form is going to be 5 times 20x minus 3 times 20x plus 1. So that's really a review of what we did yesterday, right? We talked about that. So that's right there. And what I want to go ahead is I want to go ahead and preview work on number 2 and 3 together here for a little bit before I turn you loose to work on yourself more or less. Because any questions on this one right here? Are we pretty good on this one? Reaction from the crowd?
Whoa.
Yeah. Okay.
Oh, what we're doing yesterday.
Yeah. And so I showed this one yesterday. Now I'm going to go to number 2, which I didn't quite get to yesterday, which is another one. So here, if you look at this one right here, what's going to be our greatest common factor of these terms here?
3.
3 looks like it, right? So let's go to 3. So if we take out a 3, now I'd like to be able to take out 6, right? But why is 6 not going to work?
Because you can't go over
Can't work.
Yeah, because 6 isn't going to work with 15, nor is it going to work with 21. So we have to pare it back, and so 3 is probably the greatest common factor we can deal with.
Yeah.
So then we say, okay, that's 2x squared minus, and so if you divide 15 by 3, that's 5, isn't it? So this is going to be 5x, and then it's 21 divided by 3 is going to be 7. So we have that. And so what we have here is a more complex type of trinomial, but still, I'm going to give you a couple alternative ways to do this. And before I got into the teaching business, or when I started out in the teaching business, I used this method right here, the box method, because I found that you'd have to play around with it, but still the same technique will work, but you have to try, there are just more moving parts. So you know your factors of 2x squared. Where's your factors of 2x squared? 1 and 2. So what you have is you're going to have 2x and x like this. So that part is pretty easy. And then what are your possible factors of 7? 1 and 7. So you don't have a lot to choose from. So you can put 1 over here and 7, and you don't know, and one of these is, so you can kind of play around here. So if I play around here, I'm going to try negative 1 times 7 up here to get this, and then you're just going to play around. What I'm going to do is I'm going to put my attempts in here. So I'm going to put negative 1 times x, that's negative x, and then 2x times 7 is going to be 14x, and then you add these together, I get 13x. Is that going to work? No, it's not, because I need this here. So what I'm going to do instead is you're going to have to change things around. And so that not working, I'm going to go ahead and back out this thing right here. And what I'm going to do is I'm going to put 7 up here and 1 down here instead. Okay, so here's 7 and here's 1 right here like this. And what you have is, I'm going to make this -7 and +1. And so you have -7 times x is -7x. Then you have 2x times 1 is 2x. And so now I have, this is going to work because -7x plus 2x, that's -5x, right? And so now we can go ahead and have this fully factored. We have 2x minus 7 times quantity x plus 1. And so we've used our box method here, and so we're pretty sure that that's a correct factoring of that. So that's what we have. So there's some more trial and error to this method, isn't there? All right, does that look like something you'd be able to do,
No.
Kaylee? It does not?
Where did you get the x plus 1?
Because I have over here x plus 1.
So,
I have 2x minus 7 up here, so that's what they are. And you multiply these back together, you get 2x squared minus 5x minus
so you're
7.
using the outside of the box to fill in the segment?
Pardon me? What did you say?
Are you using the outside, like 2x minus 7 and then...
Yeah, the factors. These are the factors. When we factored, we have this as a factor. So this one here will go right here, and x plus 1 will go. All right?
Why does it go?
Okay. So there are more moving parts here, right? Now fortunately, when you are tested on this, a lot of these test questions on this might show up as kind of a multiple choice type of an issue. Yes, go ahead.
The top one, the purple, is that purple or blue?
Yeah.
It kind of has these all the other, whatever, the nice one. So, where did that come from?
Where did what come from?
The purple part.
This?
Yes.
From the pen?
No, shut up.
Okay, this part right here, where did that come from?
So like we're trying to, instead of just go straight into the box thing.
Yeah, we had to do an intermediate step. First we had to do this one step, which was the greatest common factoring of the 3. So we pulled this 3 out of this 6x squared. So that became 2x squared, right? 3 times that.
We don't have a common.
Are you talking about problem 3?
Okay, I know.
So I'm gonna go ahead. Next I want to look at problem 3, but I want you to go ahead and just look at this and kind of focus in on this one and see if you can understand these moving parts, more moving parts, right? And this is probably about as deep as we're going to go into factoring quadratic trinomials this year. And this one right here is slightly more advanced factoring than just the ones we've done before today, right?
Yes.
So that's part of where we're going. Because what we're trying to do is we're trying to look at a skill level, master that, and then we ratchet up our rigor, degree of difficulty a little bit. And so that's where we are. All right? Now, I had Lillian ask me about number 3, I believe. So let's look at that. And one thing you have in your favor with number 3 and also number 2 is that when you're trying to factor, there are not a whole lot of different ways to go with 2, right? You know it's going to be 1 times 2, you know 7 is going to be 1 times 7. So that means you don't have to try many combinations before you're going to get to the thing that is factorable. So that's an advantage of that. And similarly with number 3, that's the same. Yeah, Lillian, we don't have a common factor at all, do we?
Yeah.
And so we really can't do that first step that we did on problem 2. So what we're going to do is set up a box like this again, and a box method. And then so we put 3x squared here, and then 7 here. And then what are your factors of 3x squared going to be?
3 and 1.
3x and x, right? And what are your factors of 7 going to be?
1 and 7.
1 and 7. So I'm going to put 1 and 7. Now I know that's negative, so I know these are both going to have to be negative,
Oh, God.
right?
Wait, what? What's negative?
This is negative. This is negative, so I know that my factors of 7 are going to have to be negative. Because there's no way this can be negative unless these two factors are negative, right? So what it is when you get familiar with factoring, you learn to pick up these little clues along the way. Okay? And so what we can do is we can go ahead and say, all right, negative 1 times x is going to be negative x, and then negative 7 times 3x is going to be what?
21.
Yeah, so negative 21x.
I put the 7 at the top.
Yeah.
So is that going to work? No, it's
I
not.
put the 7.
So what you can do is you backtrack here. So you go here, and so if you put negative 7 up here and negative 1 here, and then you try this, so you have negative 7 times x is negative 7x, and then you have negative 1 times 3x is negative 3x, so then you have negative 10x, right? So this is going to work, isn't it?
Yes.
So now you have x minus 1, and then you have 3x minus 7. Now, some people don't like this method very well because it's a little bit of a trial and error method, isn't it? So you have to do that. There is a method of doing this that is not trial and error, but I find that when you have a situation like this where you have there are only really 2 possible factors of 3, right? So that's not going to complicate things very much. Nor 7, you only have 2 possibilities for 7. So it's going to be 1 times 7 in some type of order, right? Or in this case, negative 1 times negative 7. So when you have a situation like this, a box method is really helpful. And now there is a way you can do this without having a trial and error type of situation that some people like a lot better. This next one I'm going to show you is another method, and I don't want you to, this one here, you have more moving parts here because you have 21 has 3 and 7, but also 1 and 21, right? And so this one here has there's one called the X method, or who's worked out? Has anybody worked out number 4 yet?
I'm
You have
working it
these?
out right now and it makes no sense.
Pardon me?
I'm almost done.
You're almost.
I'm working it out and it makes no sense.
So you haven't got someplace. So what I want to do is
Oh, I finished it.
what I want to do is give you another couple minutes to see if you can puzzle through number 4.
Yeah.
And then I'm going to show you an alternative method where you don't have to, it has more pieces to it, but you don't have to guess and check on this next method I'm going to show you. And so I will show you that in a couple minutes. And I'm thinking that we'll probably come back to this on Monday and work some more on it today. So I don't see us having this thing necessarily totally settled today. Now, and this one right here that we're showing, I don't really expect that you would have ever seen that even in Algebra 1 at this point. Before today, what we've seen, I thought you should have seen in Algebra 1. This one right here, this is ratcheting up the complexity, isn't it? Mason, have you seen these before like this, of this level? Some. Did you go, were you in Algebra 1 here? Where were you?
I was in the middle school.
Where?
Middle school, I did algebra.
Oh, in middle school, okay. So you took Algebra 1 in middle school is what you're saying. And you remember this a little bit? Okay. All right.
So did you take geometry last year?
Did you take, so you took geometry here last year? Where were you?
I did online for Houston.
For which school?
It was Connection Academy. So it was like a school in Houston.
Houston? Okay, so online, all right. All right, so, all right. I just wondered. Because if you took Algebra 1 as an 8th grader, that would put you on track possibly to take Algebra 2 honors and that, but I guess you're okay being here? All right. All right, good. Yeah, I had several virtual learners at the beginning of last year, and of all the ones I didn't have very many. I had maybe about 10 or 12. I only had 2 that I felt were really getting the material, working virtually. I mean, that's what I felt like. Those 2 did pretty well. One stayed virtual the whole year, and one came back, and yeah. Okay, so Mason, you have this by now. So Lillian, you got this one, number 4?
Yeah.
Okay, who else got this
I
one?
only have the books.
You did the box method. Daisy, you got this one?
Yeah.
All right. What about,
I have the block, but I don't have
so you have it filled out. What about Trevor, did you get this one?
Just
4?
have it else.
Anybody else get this? No?
Just have it else.
Ariana? No? Jack?
7.
Jordan, did you get this one? Colby, did you get this one? 4?
Yeah.
Abigail? Okay, so maybe less than half of you got this. So I'm going to show you a method that you don't have to guess and check. It's called sometimes the X method or the bottoms up method. And so it's called by, actually those are 2 different processes in the deal. Now, what happens is this quadratic trinomial is written in what we call standard form, and that's the form ax squared plus bx plus c. Have you ever seen that before? Yeah, so that rings a bell. So in this case, a is equal to 2, b is equal to negative 11, and c is equal to negative 21. So those are the things we use. And so you set up an x, and this x I'm making is why they sometimes call this the X method. And what you do on the top of the X, you put the product of A and C. So you multiply A, which is 2, by C, which is negative 21. So what's 2 times negative 21? So negative 42. And then down at the bottom of the x, you put b. And what is b? Negative 11. So now you have negative 11 and negative 42 here. You're looking for two numbers which, when multiplied together, equal negative 42, yet when added together equal negative 11. And what two numbers would those be? Okay, you can look at 7 and 6, right? That's possible, but then that's not going to work out because they wouldn't add up like negative 7 times 6. So what other factors do you have of 42? Well, 3 times what? 3 times what equals 42?
14.
14, right? So 3 and 14. So let's try that. I think that's going to work. So 3 and 14. So which one has to be negative?
The 3.
14.
The 14, right?
Yeah.
And so now you have that. So it takes a little thinking to do this, right? But you're able to go to it. And then the next step you do is you divide by A. And what is A? 2. So we're going to divide both of these by 2. And then you simplify as much as you can. Can we simplify this 3 over 2? No. And so you take this, can you simplify negative 14 over 2? Yes. Which is negative 7. So what you have, now we're ready to go to the next stage of this. We're just about done. What you have is you have x minus 7. And then you have x plus 3 halves. Now I have an equal sign here, but that's not exactly equal. Now the last stage of this thing is called the bottoms up. Any place you see a fraction like this, you take the denominator of that fraction and you bring it right up over here to this x. So that's the bottoms up part of this. And so what you have here is x minus 7 times 2x plus 3. And so that's going to be your factoring. And then you have, that's what it is. And so this is our correct factoring of this. Is that what you got for your factoring? Mason, is that what you got? Yeah. Lily, that's what you got? Colby, you didn't get that one?
I didn't.
I got 2x minus 3, and then x plus 7.
Okay, let's talk about that. Okay, here, if you have, this one right here, you have negative 7 times, now it comes to checking the work. So here you get negative 7 times 2x is negative 14x. And here you have x times 3, which is 3x. And you add those both together, you get negative 11x. Now, if you had in a different order, if you had plus 7 and minus 3 here, you'd get plus 11x.
No, I got that. I have 2x minus 3, then x plus 7.
I'll show you that's not going to work. Here's here's x plus 7, and here's 2x minus 3.
2x plus 7.
2x plus 7, and then x minus 3.
Yeah.
Okay, here you get negative 6x. I have to redo this one. Okay, here you get negative 6x, right? And here you get positive 7x. That's going to add up to x. That's not going to work. Right, so you see why that's not going to work?
Yeah.
And so what it meant, if you did you use the box method for that, Lillian, is that what you did?
Yeah.
Yeah, so what you had to do is you had to try different combinations until you got the right one that works. So that's a check of why that doesn't work. So let's go back and put our correct answer here. One good thing about this is that it should be pretty easy to check if you got it wrong and fix it. So you get x minus 7, and then we have 2x plus 3. That's that one. And really, those are, there's another thing you can do as well. You can open parentheses here and just sort of write stuff in here and play around with it until you get it right, and just kind of write back and forth. You can do that too. And to me, I make a strong argument for this method, but it takes you right to the answer, but you can see there are more parts to it. If I'm doing this myself, I can go either way. I'm telling you that my experience as a teacher, I never started out really knowing how to do this one, and it's taken me like time to get my head around this method, but it's one that eventually, having come to understand it, that most students will get this method better eventually and go right to an answer, okay? It's just more steps. This one here, it's a good method, but it takes a guess and check situation. And so what happened is Lillian, that's what she did, but she had to do a little more checking to get that one, okay? And then for 5, we have our common factor. Is that going to be 2? So we get 2x squared plus x minus 10? Yeah. Yeah, that's, so I don't know, have you worked out this one yet?
A little bit.
A little bit?
But it looks stupid, so that's not.
Doesn't make, who has number 5 so far? Anybody? You, Mason has it. Anybody else over here? Did you use a box method for that one? Is that how you did that,
I
Mason?
tried to.
You tried to use a box method?
Didn't work.
Lillian, do you have this one yet? What about you, Braden? You have this one? Working on it. What about you, Christina? Working on it, okay. So how many, Mason is a 10th grader. Which other 10th graders do we have in here? Do you have any other 10th graders? Here? So you're the only 10th grader in here? All right, that's fine. I have more 10th graders in my second period class. Logan is one of them, and I think Seth. And I think there are probably a couple others. And not having the time to really finish this today, I hope we can come back and refresh on Monday and work on it some more and get our heads wrapped around it better. Check mine. We got Shaylee's 10. Yeah, I got 3 in there. Okay,
Remembering things.
all right. Okay. How many have this one by now besides Mason? Do you have this one?
No.
Anybody else have this? Jax?
I
Kaylee?
got attention on.
You got it now? Colby got it? Do you have this one? So we got Colby and Mason that have this now. Did you get this one yet? No?
I just
What about you, Ariana? You have this one?
feel like something's not clicking in there.
Okay, so let's go ahead. What I'm going to do is, so did you use the X method for this, Colby? Is that how you did this one? Okay. Really good. Good work. So I'm going to do the X method. I think that what it is, I'm going to put AC up here. And so AC, 2 times -10, -20. And then B is going to go down here. We have 1x, so that's 1. So what 2 numbers do you multiply together to get -20, but add together to get 1?
Negative 4 and 5.
So yeah, so -4 and 5. So I'm going to take, actually you have pods, so 5
Okay.
and -4. You see that? And now we divide by A, and A is 2, right? And we simplify where we can, so we get -2 right here. So we're going to bring this down as 2 times. We're going to put x, there's your -2. And then we're going to have x plus 5/2. Now, it says equal, but it's not exactly equal because we have that divided by. So this is not exactly equal here, but it's part of the process of solving. But this is going to be equal here, right? So we have x minus 2, and here we bottoms up this guy here, so we bring this 2 up here, so we get 2x plus 5. And so now, is that what you got for that, Colby?
No.
No? What did you get?
I don't know. I got the 2x plus 5 right, but I didn't get the other one.
You didn't get the x minus 2 right?
No, I got an x minus 4.
Oh, you got x minus 4, okay. Okay, well, what you should get is if you had 2x minus 4 times 2x plus 5, you could get that, and you get this, but then you wouldn't have this 2 factored out, right? Yeah. So the thing you have to do, you have to do this greatest common factoring first to get the fully factored form, which is this one. Okay? So the steps. Let me get this erased here. So this one right here. Yeah, has anybody finished number 6 yet? Okay, what I'm seeing, I'll tell you, I'm just looking around the desks, and I'm seeing a lot of papers put away, okay? What happened to the papers for class? See, there's one missing here, 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 here. What happened? What happened to the papers? I guess I'm trying to make a point. Class is not over, right? That's my point. Thank you. Okay. Who has number 6 yet? Anybody? So Colby, Mason. We want, as the train rolls along, we want more to catch on. We got 2, looks like, that are pretty well caught on the train. We want to get everybody caught up on this. Okay. End of class. It's the end of class. We've got the last minute or so of class. AC goes up here. So we get negative 36. And by the way, there's no common factor here, right? So you have negative 5 here. And what 2 numbers are we looking at?
Negative 36.
Negative 36, you multiplied 3 times negative 12. Well, factors of this, I'm thinking, which ones?
4 and negative 9.
4 and negative 9. So Colby says negative 9 and 4. And then we divide by A, which is 3. So we get negative 3. So what we're going to have is x minus 3. And then we have x plus 4/3. And we bottoms up this thing here, this 3. So we're going to get x minus 3 times 3x plus 4. And that's going to be our correct factoring. And I know that because this is not a guess and check process. You do that, the process, you know you have a right answer. Is that what you got, Colby, for that one?
Yeah, I got it.
So anyway, we're going to just keep your paper. We're going to work on this more Monday, and I'm going to have an assignment for you to work on that's not as difficult as this tomorrow with your substitute teacher. Okay? Thank you.